Hi everyone, my name's Andrew Richards and welcome to the SysInternals ProcDump section of the SysInternals 25th anniversary event. As I said, my name's Andrew Richards. I have been the co-author of ProcDump with Mark for about 10 years now, since about version 2 or 3. Also happen to be the host of Channel 9 Defrag Tools, was a series of about 200 episodes that delves into troubleshooting, so something else for you to dive in after the event. And my day job is a principal developer in Windows Reliability, making Windows more secure and reliable as we go through the years. Today we're going to be going over what ProcDump is from a basic level, not too deep a dive. It's got lots of features. We're just going to do the basics that will help you to become a better user of ProcDump day to day, a better debugger of dump files, and basically be able to root cause or at least identify where you are with your crashes and hangs in your applications. ProcDump is available at the SysInternals website, sysinternals.com, also aka ms/procdump. The topics we're going to cover today particularly are what is the file that we make, why is it called ProcDump, what is this process dump file. We're going to get a debugger so we can open those files, and then we're going to go through two main scenarios, crashes and hangs. Collecting some dump files and then digging into those. So first off, what is a process dump file? What is this weird name? A process dump is a way of taking a file version of an application. Think of it as a snapshot. The process is paused, so it's kind of like not moving forward. And then all the memory associated with the process, so things like variables and globals, and also memory to do with maybe threads and stacks, plus metadata, things like performance counters and its memory usage and CPU usage. All that is captured and put into a file. The file is called a dump file. And over the years, there's been a couple of file formats used for dump files on Windows and also on other platforms. ProcDump uses the minidump file format, which is not to be confused with the minidump mini-sized file. The minidump file format allows you to specify a range of sizes, so you can have a mini dump, a mini dump, all the way up to what we call a full mini dump, which is all the memory that is possible. ProcDump always writes its files using a .dmp extension. Windows error reporting sometimes uses in certain scenarios HDMP and MDMP. They're still the same file format. It's just an indicator that this file has heaped memory in it versus mdump, which would be mini size only. All the same file format. It's just, as I said, a hint as to what the file can do. The capture of a dump file can be done in various sizes, and the main three are mini, all, and mini plus, which is kind of in the middle. Mini is what Windows error reporting uses. It's the simple, just what's required to understand the situation, but you won't be able to do that deep dive analysis. Mini all, complete end of the spectrum, it's everything. It's all the memory. And then in the middle, there's a one called Mini Plus, which is a ProcDump concept where we try to just get what's required, but kind of be sure, or try to be sure about we do have enough memory to investigate a situation. If you have a really big server, where say like maybe 100 gigabytes, it's a way of bringing that down to a more reasonable size in the 10 to 20 gig range, for example. There's a couple of rarely used things. Triage dump files, the same as Mini. Windows has a heuristic that ProcDump uses to try to identify PII and change that to AAA in hex. The idea being we're trying to remove strings and personal information. It's not guaranteed, it's heuristic, but that's there. Mini custom, in the bottom of how this works, it all comes down to a hex bit mask. And so you can just type in that hex bit mask directly rather than relying on one of the pre-baked numbers. MD is for a DLL callback. So if someone wants to be a mini dump, write dump callback, which is this thing you can look on MSDN, you can provide that DLL. And then there's kernel, which is slightly different. So all of those so far define how big the file is going to be for the user mode dump file. You can also attempt to take a kernel dump file as well at the same time. So you'll end up with two files for the capture, and it takes the kernel side of the process. And You use that particularly when you're doing hang analysis, where you want to, the user mode code is waiting on something and you want to see why it's waiting in the kernel. You can use VMMap to get an idea of all the different segments of the process and what may or may not be brought in. Things like image, map files, and heap, the various types of private memory heaps and stacks, and private memory itself are the main things that we're playing with here. ProcDump defaults to a year, month, day, hour, minute, second file name format if you don't override it. If you happen to take multiple sizes at the same time, and whether this be I want a mini and a full at the same time, for example, or a mini plus a kernel, you'll get a suffix of that size. Pretty rare that you need to override it as a different file name, but the option is there. So let's jump into a debugger session and just collect some dump files. So I've copied ProcDump into a dumps folder. And what we're going to do is just going to run Notepad and take some dump files of it. So without any options, it's going to take a mini dump. And what it's going to do is match anything with the name that's unique enough. And as long as there's one, it will be happy. So for the case of Notepad, there's only one. That was a mini. So I'm going to do a mini plus as well, MP, and mini all, or memory all, MA. And if we look at the folder now, we've generated 3 files, and you can see seconds went up as we ran each one. And this was the mini, 700K, mini plus 30 meg. The memory all, the full was 100 and something. So you can see that variety of sizes that you can get. And as I said, these two are roughly the same as from a debuggability point of view. If you are running, debugging or dumping like a really big process and it may not succeed because it's so long or so hard to dump, you actually can take multiple at the same time. So the idea is you get a smaller one guaranteed, and then the big one may or may not succeed. So pushing this to the extreme, I'm going to take 3 files at once. And you can see that all 3 were taking at the same time. And in this case, because they were like a set, the size is put on the end. So let's jump back into what are you going to do with these files? What's the next step? So we need to get a debugger. Microsoft produces 2 main debuggers, the Windows debugger, which is a very CLI command line approach to debugging, and Visual Studio through code and all the other variations of Visual Studio. That's more of a GUI-based approach. Today, we're going to be using the Windows debugger style of it, the CLI, because I want to show you the nitty-gritty details of what actually is in a dump file. Within that space, there is 2 options. For the last decade or so, the debugging tools for Windows has shipped in the Windows SDK. And more recently in the last couple of years, there's now a Windows Store application called WinDBG Preview, and that's what we're going to be using today. The debugger is extensible. There is a plugin framework, and so you can add extensions of various types, particularly 2 extensions that are worth adding to your toolset are PDE and MEX. PDE is very good at debugging UWP applications. It has a whole lot of tool commands to help in that space. And MEX is much more kernel focused. So this is more your kernel blue screen dump file. Suggestion is pull them down from their website and just put them in the same folder as your dump file folder. I find if I put all the files together, I don't lose them. So let's have a quick look at where those are on the internet. So WinDBG is in the store. Get it, install it, pretty easy. ProcDump is on systemterminals.com, www.systemterminals.com, or aka MS ProcDump. The Windows SDK continually evolves as Windows evolves. You can download the ISO version of it or the installer. You only need to choose the debugging tools out of the package. You don't need to choose everything, so it's only a couple of megabyte download. MEX is available on the Download Center. It's a zip exe, so you just download it, extract the DLL, and then use the DLL. PDE is available on the Defrag Tools, Channel Defrag Tools homepage in this OneDrive link. Also, if you want to dig in deeper, and particularly for the MK option, the mini kernel option, memory kernel option, Defrag Tools episode 178 goes into deep detail about what that looks like and how to use it and what scenarios. So Let's talk about what you're going to do with a dump file once you have it. If you don't know really anything about debugging, the easiest thing to do is open up the file in WinDBG, either the old one or the new one, and just run bang analyze -v or bang analyze pure. This is the same engine that Microsoft uses to back Watson and our telemetry, and this is how we map bugs against issues. And so with no debugging knowledge, you're really going to be driving, getting the insights that Microsoft provides with the bang analyze tool. But let's do it ourselves. Let's dig into real world environments and move from there. So the first step is to get some dump files. Crashes are a good way to start, and they're easy to find or something easy to do. Operating system has a thing called AE debug. It's part of Windows error reporting, and when a crash happens, it runs the AE debug handler. And so by installing ProcDump as the AE debug handler, you're going to get the an opportunity to collect a dump file out of crash. To install it, it's from an elevated command prompt, ProcDump -I. The folder is optional. It uses the current folder by default. The size, if you don't specify it, will default to mini, which is a little bit small. So you actually want to specify a size. If you have hard drive space, do memory all. That way you guarantee to have everything you need. If your hard drive is a little bit smaller, use mini plus and collect your files. And then the opposite, just use -U to uninstall it. So once you've done that, and we can show you that in action right now, I'm just going to install it, get full dumps, install, uninstall, oops, uninstall. You can see it deleting the registry keys and adding the registry keys. So in this case, we've got it installed. I'm just going to go in here and run a crash app. And it's going to run two of them, two different types of crashes. And you can see that it generated some files. And it's always going to be 2 per system. The reason why you get 2, sorry, I was switching screens then. The reason why you get 2 is because the operating system tries 2 times to resolve the situation. The point of AE debug is to ask someone to fix the situation, not to collect a file. And so in that case, we don't fix it the first time. All we've done is dump the file. Windows error reporting calls you again, and then after the second time, it goes, okay, obviously this can't be fixed, and then continues on to finish the application. Because of that, you can just delete the second file. Now you notice that this one's got a .1 or -1. That's because that was the second dump file taken in that second, and in this case, it went over the second boundary. So the second moved up, so you can delete those. When it comes to the debugging of them, the main thing you want to do is follow these steps. This is the general steps to run when you have any generic dump file that's a crash. Last event is the first command you want to do. It tells you on what process and what thread the issue happened and what exception it was. Just gives you a general idea of what context this happened in. ECXR -1, exception record. The -1 tells it to read the parameters, exception parameters out of metadata, i.e. out of the dump, rather than out of memory. And what it's going to do is give you an extra level of detail about the parameters and the reason for the issue. ECXR, exception context record, will change the default focus of the debugger to the throw. And what I mean by that is when the issue happens, it is thrown and then it is caught. So it's caught by Windows error reporting. What we want to do, and then the state has changed because Windows error reporting is running, we want to wind back time, the registers, the way that the system looks, back to the throw and look at in that context. The K command, which is stack, works at any time. If you follow this flow, it will be the call stack of the crash. There's one specialization, well, there's lots of specializations for exception code, particularly there's a specialization for CLR exceptions. If the code is CLR exception, and you'll see that in the last event output, then you want to run .core DLL -L for load, and that will load additional infrastructure in the debugger associated with CLR debugging. And particularly, it will make a command called bang-PE, which is a shorthand for bang print exception. And that will have a more rich way of printing out the exception. So it's kind of equivalent to ECXR -1, but it's specific to CLR exceptions. So let's have a look at some of these dump files that we've been creating and see what that looks like. Opening up ProcDump, opening up the ProcDump crash file in WinDBG. Right away, I'm just going to press K. You can see that we are in Windows error reporting. The crash has happened down here. It's gone through Windows. Windows error reporting is kicked in. And this wait for multiple objects is actually waiting for ProcDump to take the dump file. As I said, you can always run bang last -v at any time to get the answer. But we're going to go into the specific details. So .last event just to show you what happened. So on process this number, thread this number, there was an access violation. The tilde command just happens to tell you where the debugger is currently right now. Same numbers. Because this is set, the debugger will default to the same thread. Just the fact that it's thread 0 is by luck, not by design. Next command is EXR-1, show me the exception. In this case, it's an access violation. The 1 means it's a write, so 0 is read, 1 is write, 8 is execute, and then we have the address it tries to reference. If we do ECXR now and change our register context, you can see that the debugger has transitioned it from really the catch, which is what this is, to the throw. And here's the line of code that crashed. So let's quickly do that for some other dump files that we have on this box. .last event, divide by 0, so we already kind of understand what we're doing here. Exception record, no additional parameters, change the context, and then you can see the line of code and the instruction that crashed. More commonly is when you do this in real life. And so for the -I example, these have happened on my box, and all these ones I've kept around on my box for examples. Last event, access violation, -1, parameters. This time it's a read because it's a 0 and a different address, ECXR, and then we can look at the code and we can see that there's a fault in the install service. Let's look at, actually I'm going to open both these up. I think next time, this one is a security failure. Looking at the number, it is of subcode 7, which is a specific thing, which is app exit. It has this error code. So we can say, what does that mean? Class is configured to run as a security ID, blah, blah, blah. Change the context, look at the code, and then you can see the line of code is reporting the failure. So it's somewhere around here that the fault is. This last example that we have from our hard drive, last event, CLR exception this time. You can see the CLR exception code, 5 parameters. There is an error number right there. Now the Fs are on top because it's sign extension. So because the last bit, the top bit of the 8 is set, when you cast that 32-bit number up to 64, the 1 is repeated. That's how like -1 works. Negative numbers work. So here's our error. In this case, we can jump to the context, and you can see CLR being busy. But what you really want to do is follow those steps, call DLL -L to load. You can now see it's loaded, and we can do PE for print exception, and we get a much better view of the world. And in this case, you can see there's some dictionary code going on. Argument exception, an item with the same key has already been added. So the same key was added to the dictionary. You can see the call and code. If you had symbols, you could dive into a bit more. And once again, the same error code as we saw above. All right, so very quick whirlwind way of looking at crashes. So let's start looking at where the power of ProcDump kicks in and start using some of its tooling. There is 4 or 5 different ways of ProcDump can do collection. We can do it based on CPU going too high or too low. So if a process runs away on compute or under runs away, it goes under. The pair to that is memory and performance counters. If the memory goes too high or too low, or if a performance counter goes too low. And the other ones are more kind of like state machine weights ones. You can do it based on an exception. So if you may have a throw that is caught, but the throw represents a situation that causes maybe an application to become unstable. rather than being critically killed. So that's what exceptions is for. -H is hung windows. That's when you want to diagnose into a grey screen where an application freezes and ghosts. And then the other one that's not used very often is terminate. That's when you literally terminate yourself. You can call the API process terminate, self-killing. So you want to find out what code caused that. And then how many seconds applies to those things. So how many seconds in a row does it need to happen? So let's use ProcDump again to trace Notepad again. This time we're just going to do CPU. Now I don't know how much CPU Notepad uses, so let's just start with 99%, like nearly all the CPU of the box. And what I'm going to do is just type a lot of stuff and copy paste it. And then we're going to run Process Explorer at the same time. And we're going to find this process. And we have its performance graph. So here's its CPU usage. So what I want you to do is pay attention to here as I paste, and also pay attention to Process Explorer's count. So as I'm doing this, the pasting, it's kind of expensive, 1%. I'm going to copy a bit more, so there's a bit more involved in the paste, like the whole document. And it's hovering around 4 or 5%. So this time I'm going to reduce the load to 2% and keep on pasting. And now you can see, look, we've noticed 4%, 6%, but I'm going to let go. And so because we haven't got to the seconds, the number of the seconds by default is 10. So we can cancel that and go, look, I only need it if it lasts 3 seconds, for example. And I'm going to get a full dump, for example. Continue my pasting, triggers firing, triggering, and then we've made a dump file. And then if you open up the dump file will default to the thread that had the most usage. And if you use the command bang comment, you can see what ProcDump observed and on what thread. So more, that's like kind of the performance counter view of the world. So let's do something a little bit more invasive, and let's look at ProcDump. So let's look at this Trace Explorer. So I'm going to look at Explorer, and I'm going to filter for nothing. So I could filter for something that doesn't match or a blank string. You can't match a blank with a non-blank, so that's also guaranteed. And we're just going to look at Explorer. And so I'm going to use Windows pause to bring up the About screen, and then I'm going to close it. And you can see there's a slew of events on the screen. MSC in lowercase ASCII is actually 6D7363. This is Microsoft C. So this is the C++, C++ exception code. And you can see these are all C++. So they're kind of codey, kind of normal. This one's kind of weird, the 4001. So let's catch that guy. And I can choose to match anything. Any part of the string can be matched. So I could use this part, anything that matches. And I'm going to say, you know what, I want the first 2 of these, 1, 2, but I don't want the third, for example. So run up the demonstration again. You can see the first one capturing. It's going to skip over the C ones, and then you can see the second one capturing, and then it ends because we've satisfied the queries. Opening up one of those dump files, we can follow the same steps for crashes in this case because it is a crash scenario. The slight difference is ProcDump has taken the dump file at the throw, not at the catch. So we don't need to change time at all. We can just do last event and see, yep, when times, there's the error code. Show me the exception information. It has 3 parameters. Once again, it has a code, and we get an information about that. And as I said, because we're at the throw, not at the catch, we can just press K and see the code. And you can see some reporting code, and this is the code around here somewhere that originated the issue. Okay, so looking at that in text form, we can take dumps at first chance and second chance, first chance, the minus E1, is when something is thrown. The second chance is when it didn't get caught and it crashed. It's exactly the same scenario as you can go minus E2 or minus E nothing. Same scenario as what would happen if we had the code written as an install handler minus I. So it doesn't tend to get used. You can use more than one filter. You can use positive and negative filters, including and exclude filters. A whole lot of examples. I won't go through them right now. And then, as I said, this is the thing that we traced before. Some really esoteric options that we'll just quickly go through. Minus B treats breakpoints as exceptions by default. Our breakpoint is ignored and just continued when we're doing exception monitoring. But if the breakpoint is needed to be caught, you can add minus B. By default, because of limitations of CLR and OS, if the CLR is detected in a process, we only do CLR monitoring and we don't do native, like normal Windows monitoring anymore. If you are trying to catch the native exception, use minus G to ignore that interop across the CLR and stay in the native debugger. Minus L is a log output. This is output debug string, so you can see that on the screen. And minus T we talked about before. Reflection and minus A, avoid outage, allows you to take the dump file on a clone, so on like a fork in Unix. And so if you have a process that needs to continue for maybe production reasons, or say that it's maybe just producing video content or something, you can make a clone, which is like a snapshot, and then it does it in the background. Avoid outage if ProcDump knows it's in a situation where it's having to pause the application for too long. Rather than taking a dump file, you can use avoid outage and it will miss taking the dump file rather than avoid an outage. In some very rare situations, you want to kill the process after you've collected it, minus K. When you're doing CPU tracing, the scale is between 0 and 100. But if it's only one thread on, say, an 8-core box, it means its range is really only between 0 and 12. And so what you can do is by adding minus U, instead of that range being 0 to 100, it changes it, say, to 0 to 800 if it has 8 CPUs. And then you can use a number between 0 and 100 to represent that. It's a way of giving granularity. You don't have to have the process already running. You can use minus W for wait. It just does a poll every 500 milliseconds to see if it can find the process. And basically, if you're a Windows on Windows 64 debugger within Microsoft developer, then you need minus 64. Super, super rare. So hopefully that was a understandable and easy way to get into the basics of WinDBG. Hopefully I've inspired you to practice your debugging. At least install the debugging tools, install procdump-i to get your local dump files collected, and open up a couple. You'll get, a couple of dump files every little while. Sometimes you'll have stable periods, sometimes you won't. It's really hard to tell when you're going to get dump files, but open them up. Last event, ECXR -1, ECXR and K to get an idea of where you are, and it gives you an idea of what's the next steps are. If you want a much more deeper dive, there's a whole slew of videos on the Defrag Tools series about sysinternals in general, and there's a good 10 or 20 on debugging. Hope you enjoy the rest of the conference today, and thanks for listening. Bye.
When Mark and I started to collaborate on the book, I did go to Microsoft. I went to one of the key members of the Windows NT development team at the time, Lou Perisoli, who was overseeing, I think, all of the kernel development, and mentioned the idea of collaborating with Mark Russinovich. And at that time, Mark was not on the most friendly terms with Microsoft, especially with the NT group. So basically, I said, I can vouch for Mark. He's seen the light. He wants to be a friend of the family. So I remember Lou's telling me, Dave, okay, you can work with him, but if he messes up, it's your head. We started to work together on the book, and then talking to Mark, we decided to make a request for him to have source code access. We thought that would accelerate and help with the book effort. Of course, Mark was able to do all the work without source access. But we made the request, and that, of course, went to higher authorities. But sure enough, it was approved. They prepared the license agreement, and we were both in Redmond. I think I was there teaching another class. And we were given the source code agreement. I presented it to Mark. Mark looked at it, and I remember in the conference room, and he said, "Dave, I can't sign this." And there were some clauses that conscientiously Mark couldn't sign because it said anything that he learned or discovered based on looking at the source code could not be used in his commercial programs. And the commercial arm, Windtunnels, the company that Microsoft purchased, did have tools that were products based on Mark's reverse engineering. So if he saw some of this inside information in the source code, that could potentially prevent him then from selling these commercial tools. So he had to say no. But what an embarrassment to go back to Microsoft after basically making a case that he could be trusted to see the source code and tell them, sorry guys, he can't sign.